So now that we've learned what greatest common factors are and lowest common multiples, we need to be able to remember what they are and how to differentiate between the two. So when you're thinking of lowest common multiple, remember that the M stands for multiple, and then greatest common factor, the F stands for factor. So there's many, need to also remember saying that there's many multiples and few factors. So this will help you remember when we're trying to differentiate between the two. Remembering from the previous slide that the multiples of a number other than 0 are equal to or larger than the number, while the factors of a number are equal to or smaller than it. So I'm going to give you some scenarios and we're going to distinguish if it's a lowest common multiple or if it is a greatest common factor. So for A, 6 is the blank of 42 and 54. Well, we can see that 42 and 54 are both larger than the number itself. The number itself we're dealing with is 6. So we know that 42 and 54 are the greatest common factors of the number 6. Okay, so I want you to now sort for B, C, D, and E and F. Is it I'll move these down for you so you can see them. Is it a lowest common multiple or is it a greater common factor? Let's distinguish between the two. When you're done, you're going to continue on with your slides. So let's consider the greatest common factors in context or in a word problem. Here's your problem. There are 56 girls and 42 boys registered for a team event. The organizers want to put the same number of girls on each team and the same number of boys on each team. All the children need to be on a team. So what is the greatest number of teams the organizers can make? So let's start with the girls. So let's we're going to start by thinking of the girls. So for the girls, we know that the number of teams, I'm going to just type this so you can actually read it. So we have the number of teams times the number of girls on each team needs to equal, we were told, 56. Okay, so if all the girls must be on teams, how many can be on each team then? So the answers that we're looking for are the factors of 56 itself. So if we think of the factors of 56, we're thinking of ways that we can make 56. So we know that we could do 1 times 56 itself. We know we could do 2 times 28 to give us 56. We could also do 4 times 14, and we could do 7. Sorry, my computer froze. We could do 7 times 7 as well to make 56, so 7 times 7. So all of our factors for 56 then are 1, 2, 4, 7, 28. Sorry, 14, 28, and then 56. So if that number of girls are on each team, how many teams are there? So there could be 56 teams. If we had one girl on each team, there could be 28 teams. If we had 2 girls on each team, there could be 14 if we had 4 on each team. So continue on with that. So now let's think about the boys. Oh, sorry, still on the same page. So if we're thinking about the boys now, we're going to think about, I'm just going to extend this on a little bit. So for the boys, we need to think about if all the boys must be on teams, how many can be on each team? Well, we would have the same sort of equation that we did above for the girls. So the number of teams times the number of boys, and that has to equal then 42 because there's only 42 boys. So now we're going to find all the factors for 42. So that we could find that the factors of 42 would find that the factors are 1, 2, 3, 6, 7, 14, 21, or 42 itself. So those would be our possible answers for that. So we are now going to ask, what is the largest number of teams that the organizers can make? So the largest number that appears on both lists, the boys and the girls, in common is the number 14. So 14 occurs here, and 14 also occurs here. So the possible number of teams for the girls are factors of 56. Possible number of teams for the boys are the factors of 42. So the greatest possible number of teams would then be the greatest common factor of 56 and 42. So with 14 teams, if we had then a total of 14 teams, each team would have to have 4 girls. So we'd have to have 4 girls, and then you would have to have 3 boys on each team. But the greatest common factor then is going to be 14. So what are all the possible ways of creating teams with 56 girls and 42 boys using the information we just found? Well, we know that we could have one team of 56 girls and 42 boys. We could just put everybody on one team. We could have 2 teams of 28 girls and 21 boys. We could also have 7 teams of 8 girls and 6 boys. And then our last option is we could have 14 teams of 4 girls and 3 boys. Now you're going to continue on with your assignment for today. So let's just move this up here. Your assignment now is going to be complete pages 129 to 130 in your Jump Math books, asking questions when you need to and checking in when you are completed, please.